Welcome to Daily Papers, the podcast where we break down fascinating new research papers into something you can actually understand.
Today we're diving into the world of large language models, or LLMs, the brains behind AI chatbots like ChatGPT. We all want them to be faster, right? You ask a question and you want the answer now.
Exactly. And a new paper called Batch Speculative Decoding Done Right tackles a huge problem in making these models faster, especially when millions of people are using them all at the same time.
So to understand the problem, we first need to know how these AIs write. Normally, they generate text one word at a time. This is called autoregressive generation. It thinks of the first word, then based on that, it thinks of the second, and so on. It's thorough, but it's slow.
To speed this up, researchers developed a clever trick called speculative decoding. Imagine you have a brilliant but very slow senior editor. That's our main powerful AI model. To speed her up, you hire a super fast, energetic junior intern. That's a second, smaller, faster AI model.
The intern, or draft model, quickly scribbles down a guess of the next 5 or 6 words. Then the senior editor, our target model, looks at that whole chunk of text all at once and says, yep, the first 4 words are good, but the 5th one is wrong.
And in that one step, the AI has generated 4 correct words, which is way faster than the editor thinking of them one by one. This process works beautifully for a single user.
But companies running these AIs aren't dealing with one user. They're dealing with thousands simultaneously. The standard way to handle this is called batching. Basically, you group a bunch of user requests together and process them all at once to be more efficient.
And this is where everything falls apart. The paper shows that when you combine the fast method, speculative decoding, with the efficient method, batching, you get gibberish.
Let's go back to our editor and intern. Now imagine the editor is checking 8 different articles at once. That's our batch. The intern gives her a 5-word draft for each article. The editor looks them over, and for Article 1, she approves all 5 words. Great. For Article 2, she only approves the first 2 words. For Article 3, she approves 4.
All of a sudden, the articles, which all started at the same length, are now different lengths. One has 5 new words, another has 2. This creates what the paper calls the ragged tensor problem. GPUs, the powerful chips that run these models, are designed to work on neat rectangular blocks of data where everything is lined up perfectly. When the data becomes uneven or ragged, the system gets completely lost.
And when it gets lost, the output is catastrophic. The paper shows examples where a user prompts, "The weather today is," and the AI, using one of these broken methods, replies, not.
Or it just spits out placeholder symbols that basically mean I have no idea what's going on. Previous attempts to solve this issue managed to get high speed or high throughput, but they completely failed on the most important requirement. The output has to make sense and be identical to what the slower, safe word-by-word method would have produced.
So the researchers behind this paper decided to tackle this problem with a correctness-first approach. Their first solution is a system they call EQ-Spec.
EQ-Spec is the meticulous brute force solution. After every single step where the articles become different lengths, it stops everything and painstakingly realigns the entire batch. It trims them all down, adds the new words, and then adds temporary blank padding to the shorter sentences to make the whole batch a perfect rectangle again.
And it works. The output is correct. It completely solves the gibberish problem. But there's a catch. All of that realigning after every single step is computingly expensive. The paper found this realignment process can take up to 40% of the total computing time. It's a huge bottleneck.
It's correct, but it's not as fast as it could be. So they went a step further and built a much smarter system on top of it called XSpec.
XSpec is the real star of the show. Instead of taking a random batch of user requests and then struggling to realign them, XSpec acts like a clever scheduler. It maintains a large pool of active user requests, kind of like a waiting room.
From that waiting room, it intelligently forms batches. It looks for all the requests that are currently the exact same length and groups them together. When you process a batch where every sentence is already the same length, they all stay the same length. The ragged tensor problem just disappears.
By doing this, XSpec completely avoids that slow 40% overhead from realignment for most of its work. It only falls back to the slower EQ-Spec method when it absolutely can't find enough same-length sequences to group together. It turns the expensive, always-on problem into a rare backup plan.
And the results are impressive. Expect achieves up to a 3 times throughput improvement compared to running speculative decoding on a single user at a time. And, most importantly, it maintains over 95% accuracy, meaning the text it generates is virtually identical to the slow, safe, one-word-at-a-time method.
What's really telling is that the paper shows that some of the big production-level AI systems out there actually get slower when they try to implement batch speculative decoding, because this rugged tensor problem is just so difficult to solve efficiently. Many have even given up on it.
So this paper doesn't just present a solution, it correctly identifies why this has been such a headache for everyone else. You can't just bolt speed-up tricks together. You have to be incredibly smart about how you organize the work for the GPU.
In the end, batch speculative decoding done right shows that by intelligently scheduling user requests, by grouping them by length, we can get the best of both worlds, the raw speed of speculative decoding and the massive efficiency of batching, without sacrificing the quality of the AI's output.
It's a clever piece of engineering that helps pave the way for faster, more efficient AI for everyone. That's all for this episode of Daily Papers. Join us next time for another look at the world of research.